Good day. My name is Marty Fulton, and I am a member of the SNIA Compute, Memory, and Storage Initiative. I am very pleased to be the moderator of this webcast today on digital storage and how it stars in the media and entertainment industry. A few legal points. The material that we're presenting is copyrighted by the SNIA, and it's a project of the SNIA, so please don't copy it or reproduce it. And there are no warranties, express or implied, so use this presentation at your own risk. A little bit about SNIA before we get started. SNIA is an industry organization that's over 20 years old, focusing on developing standards for storage and networking, and also to educate the industry on storage and networking technology. SNIA has 185 industry organizations around the world, 2,000 active contributing members that contribute to standard specifications, and we support and educate over 50,000 users worldwide. Easy to find us at www.snia.org. Today I'm very pleased to have as our speaker Tom Coughlin. Tom is an active member of the SNIA for many years and is currently the chair of the SNIA Compute, Memory, and Storage Initiative Education Committee. He's a widely respected digital storage analyst as well as a business and technology consultant. Tom has over 35 years in the data storage industry with engineering and management positions at high-profile companies. He has many publications and 6 patents to his credit. Dr. Coughlin is also a regular contributor on digital storage for Forbes.com, so I hope you'll check out his blog, and he writes also many other blogs. He's very active with SMPTE, in SNIA, as I mentioned, and the IEEE, where he's a fellow. Tom will have some remarks later on his involvement with the IEEE. So with that, I'm going to turn it over to you, Tom.
Thank you very much, Marty. So here's an outline of the things I want to cover here today. And thank you, by the way, for joining me. First of all, I want to talk about digital storage and data trends during the pandemic and tie that into the whole media and entertainment space. Then we'll talk a bit about some of the characteristics of media and entertainment content. We'll look into storage as it's used in media and entertainment, and then we'll focus in particular on what's been the impact of the pandemic on remote work and the growth of cloud-based workflows in media and entertainment. Finally, some conclusions and summary, and then a reference. So this next slide, please. So the COVID-19 pandemic, as everyone knows, changed the way we entertain ourselves, starting in March, when a lot of people went on remote work. We saw a huge rise in video streaming. A lot of people were at home. Many people weren't working or working less, or at least not commuting. And they had a little bit more time to entertain themselves, and probably also some real good reasons to try to entertain themselves. And the result of that was a huge increase in the use of streaming services and of network connectivity. And that network connectivity, enabled by the technologies that perhaps many people on the who are on our webinar are involved in, resulted in not only entertaining ourselves, but also enhancing communication. Video-based webinar type communication became a big deal, and basically helped to sustain our economy during the COVID pandemic. And there's a slide on the lower right-hand side there that kind of gives an idea of some of the growth in meetings that people were having as a result of COVID-19. Next slide. Now, COVID also led, because it was increasing the demand on data centers for streaming services, to support telecommunications for webinars and things of that sort, it's led to a significant growth in data center storage. This actually is a slide from Seagate, their nearline storage demand trend. But with annotations, this is from their Q3 quarterly announcement. And you can see that, and basically it shows that there's been continued growth in demand for these nearline drives, which are a lot of the secondary storage now in data centers. And both SSDs and hard disk drive storage shipments had significant growth both in Q1 and also Q2, and in general overall in 2020 compared to 2019. because of the increased use of cloud resources. And some of this additional storage capacity supported remote media and entertainment workflows. Next slide. So, and what happened was, well, for a lot of production was basically shut down for several months. And when it did come back, it was very different. You kind of get an idea of that here, this image of Universal Studios set. Today's sets of extra protection measures to help avoid infection. This Universal set entrance has temperature monitoring, for instance, for people going onto the set. They use social distancing, wearing masks, and they clean various gear, which includes storage cards and storage exchange media. And that's considered to be important elements in maintaining a safe workplace. Uploading content to an online source for remote proxy viewing and collaborative work also became much more common practices, as well as the use of Slack and other sort of remote collaborative resources. Next slide, please. So let's talk a bit about some of the characteristics of media and entertainment content, and then we'll get into just how those needs are met by storage products that are available today. Next slide. Let's talk first about resolution. This image gives a visual comparison of the number of pixels for various video content resolutions. And the number of pixels is the vertical pixel, number of pixels on a screen, by the horizontal number of pixels on the screen. And this slide here shows resolutions from standard definition content to super high vision, often known as 8K content. Again, resolution is the number of pixels per image. The greater the number of pixels, the finer the details available in the image, and the more immersive is the resulting content. The image resolution required for that sense of immersion is a function of the size of the display screen and the size of the display screen and the distance of the viewer from that screen. Note that 8K content produces significantly larger files than 4K or 2K. Digital Cinema 8K generates about 13 times larger capacity per hour than 4K and 128 times larger capacity than 2K. And in addition to this, 360-degree content captured virtual reality or potentially augmented reality are driving 16K resolution capture, which can provide 8K per eye. Now, in order to future-proof their content, many modern video professionals shoot their content at the highest resolution that they can afford. Today, that is increasingly at 8K resolution. Cameras with the greatest, next slide, please. Another important characteristic is high dynamic range. Cameras with the greatest dynamic range, that's the light levels that they can capture, have the most sensitive light sensors, or they may combine multiple frames with different exposure settings of a scene to enable more details in the dark and light areas of the image. An example of that is shown here on this slide, where we see two images that, when combined together, enhance the resolution and view of all aspects of the image. Now, high-end cameras that would do this have also high-quality optics that are designed to capture as much light energy as possible, even from dark image regions. That's important if they have a single sensor doing this. But again, many cameras do this by capturing at least two different images. Higher dynamic range using two images can increase the captured content frame capacity by up to 100%. For instance, Red camera's HDRX setting doubles the storage capacity per hour of shooting. Next slide. Another important element is the color gamut. Now, it's color depth is one aspect of color representation, which actually can increase capacity. The other important aspect is color representations, how broad a range of colors is being expressed, and that's called the color gamut. Now, the color space recorded on a camera is usually a subset of all the colors, but that is light frequencies that are sensitive to the human eye, although some cameras have sensitivities at higher or lower light levels than those of the human eye. In general, though, although this is an important element in display, it doesn't really change the storage capacity or the number of bits per pixel, because it's basically just submitting to a lookup table. But it is very important in imaging and worth mentioning for that purpose. Computer-generated, next slide. Computer-generated content is another important factor. As the price of processing comes down, some effects can be rendered in real time during the editing process. And regardless of whether content is captured or created, again, it will always be at the highest quality possible. Next slide. So here's some example, just looking at 8K workflows and just how big some of this content can be. On the left-hand side, this again is from an Hollywood Professional Alliance retreat talk in 2019. And it shows, for instance, 8K content. You see the signal display on the left-hand side table there. You see the refresh rate. That's basically that's the frames per second. Different color modes, the bit depth, and the resulting data rates. And you can see we can end up with fairly significant data rates of actually compressed content in this camera, 171 gigabits per second is what it's showing here. This then would be fed into editing workflow, for example, is shown on the right-hand side there. Next slide. Let's talk a bit more about virtual reality and 360-degree video. With the rise of small professional cameras, multi-camera projects are quite common. Capturing content from multiple cameras is a driving force for the creation of modern virtual reality content, but it also produces raw data that can be processed and used to create perspectives from anywhere within the field of view of a group of synchronized cameras focused on a scene. We'll talk a bit more about this in just a little bit. VR and 360-degree video projects require capturing simultaneous content from many cameras at once. Sporting and other multi-party events also use multiple cameras to capture content from multiple perspectives. Again, 16 by 8K video frames may be needed to provide 8K per eye. The raw video footage from the multiple cameras results in lots of digital storage and bandwidth in order to move it around. And right now we're in megapixel images, but gigapixel images could be possible in professional video production in the next decade. In fact, at the NAB and IBC show, there have been several companies selling products that include multiple video cameras capturing content from many perspectives simultaneously. An example of one of these VR cameras, next slide, is the Jaunt 1 360-degree camera. It basically has, it's a 20 megapixel rolling shutter sensor with frame rates up to 60 frames per second and 3200 ISO max, 29 dB signal noise ratio at ISO 800. It provides 20 gigabyte per minute uncompressed content, so that can fill a 1 terabyte SSD in 5 minutes. So customers, as a result, are forced to use compression in order to use currently affordable storage devices. This compression then creates 11 gigabits per minute, which can fill a 1 terabyte SSD in a more reasonable 90 minutes. Next slide. So we talked a bit about 16K video. There's some examples out there. Here's one. Because this camera actually shoots at 8K by 4K resolution, so it was necessary to first demosaic the image data to get to 16 by 4K. But then because of the screens they were showing this on at the airport in Tokyo, they brought it down to a height of 2K. And so this is an attempt, one of the first attempts to use a single camera for this kind of display capture. It eliminated the need for setting up and coordinating multiple cameras because it was a single camera, and then stitching the results in later. So that allows to be more easily captured on site and less processing later on. Conventional approach, which we've mentioned before, is to use multiple cameras to capture stuff, which, by the way, would allow you to get more of a three-dimensional or potentially even volumetric image of the thing. Next slide. Now let's talk a bit about getting into new things that people can do with multiple cameras. And one of those is free viewpoint video. So there's companies in Japan and also in Europe that have developed input from 4 to 30 simultaneous video cameras with up to 4K resolution per camera. And the video from these multiple cameras are combined together to create what they call free viewpoint video, where a viewer can look at scenes and people in the field of view from any perspective. CAN has done a lot of work in this area. In fact, at the CES show, I see it's going on right this week, the virtual CES show. In fact, they're talking about their volumetric storage, which is a type of this free viewpoint video. So this Canon system comprises several high-resolution cameras set up around, for instance, a stadium. They're connected to a network controlled via software to simultaneously capture a game from multiple viewpoints. Afterwards, image processing technology renders the video as high-resolution 3D spatial data where users can freely move a virtual camera around the 3D space, resulting in videos that can be viewed from various angles and viewpoints. For instance, you can follow the runner down the field with the ball. Next slide. And this gets into this bigger, even bigger potential and more immersive video type called volumetric video. So at the 2016 NAB show, a company called Lytro, which is the San Francisco Bay Area imaging startup company, which is now defunct, demonstrated their Lytro cinema camera, which basically captured even more immersive content and used up a lot of storage capacity. This camera used an array of micro lenses and light sensors to capture samples of all the rays of light within a scene, which can be used to recreate this captured content, focusing on any element within the field of view and allowing content editing features not possible after shooting with conventional video cameras. So the Lytro products was the size of the individual 4K equivalent frames was 750 megabytes, much bigger than a non-volumetric image each. And the video was shot at 24 frames per second. The camera is capable of 300 frames per second, but probably at lower resolution. So at 24 frames per second, that comes to a data rate of 17.2 gigabytes per second. And at this data rate, an hour of content would be about 61.9 terabytes of storage. And obviously, it needs some pretty significant hardware to be able to support that data collection and transfer. Lytro no longer exists, but other companies have been pursuing this, including Intel, which has had sessions on this topic at various conferences, industry events, and it's a 10,000 square foot, 4-story volumetric capture studio in LA with over 100 high-resolution cameras. What's particularly impressive for this technology from a digital storage point of view is the size of the captured content. There's a company called Lightfield Labs, which started by one of the founders of Lytro, at a 2019 conference, said that more than 540K video display might be required for a video experience similar to the Star Trek holodeck. And the picture on the right-hand side is an image of, what that, just to remind you what that means. So next slide. Now we're going to talk. We talked about some of these characteristics of video. Let's now talk about digital storage and its use in media and entertainment. Next slide. First of all, here's a picture of digital entertainment content workflow. And just showing you this, you can see the digital storage technology is used throughout the media workflow. The characteristics of the digital storage technology used depends, again, upon the particular application. And one interesting thing about storage for media and entertainment, it uses fast storage, it uses vast storage, it uses all the different storage and memory technologies you can imagine for various things that it's doing, because it needs to keep the content as long-term value, so it's used in archive, but it's also used in very fast capture, as you can see from our discussion earlier, and editing. Next slide. So Coughlin Associates, we do an annual survey on media and entertainment professionals and their digital storage needs. And here's this is talking about professional camera trends based on the survey. And you can see that flash memory is actually a significant part of the storage capacity used for camera capture, about 67%. However, some stuff that's done in studio could actually work on hard disk drives, and that was about 29%, with optical discs in film and magnetic tape taking a little bit more, at least in the survey population. And in many video projects, many hours of content are shot for an hour of completed work. And you can see here a breakdown of that, and a significant amount of hours, tens of hours, and even possibly approaching 100 hours in some cases were required by some of the survey participants in capturing resulting in 1 hour of completed work. Let's go to the next slide. So this leads us in the report, 2020 Digital Storage and Media and Entertainment Report from Coughlin Associates. These are our projections for the annual storage capacity growth for digital content acquisition. Because of the at least temporary stop in production work in 2020 and its limited return, we can see significant decreases we can see that 2020 resulted in much less new storage capacity than, for instance, 2019. However, we believe in 2021, with new safeguards in place, with a vaccine getting out to more people, that we will see some return to growth, but also driven by, of course, higher resolution content, the fact that people are watching a lot more video, more times. They aren't in theaters, but they're watching it at home. Will drive, again, a recovery in demand for storage, which then will increase as we go forward, driven by these higher resolution, more immersive content, and the capability of viewing it at home or possibly in theaters again. Next slide. So let's look at storage for post-production nonlinear editing. We'll break down some of the different parts of the workflow for media and entertainment. So we see that these video editing stations may use local storage of some sort. They also use DRAM or potentially Optane for local memory and editing station. Then they may also be connected to a network with some sort of NIC card, and that may be part of either a SAN. SAN is actually widely used in many video environments. Storage area network, where it's a block-based access to the data, or a NAS, which is a file-based access, or increasingly, and especially with remote work, in the cloud. And let's go on to the next slide. So this one we're talking about, based upon the survey results, the use of network storage and direct attached storage based upon the size of a facility. And so this again is from one of our surveys. And you can see that there's a general increase in the use of shared network storage, such as SAN or NAS, and a decrease in direct attached storage as the number of people working in a production facility increases. However, even for large facilities, there's still a fair amount, say 40 to 50% usage for direct attached storage. Some other survey results on this were that 81.1% had direct attached of the survey participants in 2020 had direct attached storage. 85.7% of those had more than 1 terabyte of DAS, direct attached storage. 1 to 50 terabyte was the most popular direct attached storage size, and 17.9% of the participants had more than 50 terabytes of direct attached storage. Most survey participants are not using flash memory in their post-production direct attached storage, although some did. This was an average in 25% in 2020, and that's up about 7% from 2019. 60% had NAS or SAN in 2020, and 55% had 50 terabytes or more of network storage in 2020, with about 35% having more than 500 terabytes of NAS or SAN storage in 2020. Next slide. So let's talk about using the cloud as a storage tier. You saw we mentioned that in our slide showing post-production network. So with these collaborative workflows, and especially with people working from home, cloud storage, either public or private, has become more and more popular to provide material that can either be downloaded for local processing or processing directly in the cloud. Now, to control cloud storage costs, because oftentimes, for instance, there's egress charges, the content stored in the cloud is often a copy, and the content won't be downloaded again, just changes in the content from the workload. For instance, edit decision lists for work done with remote linear editing. That's one, there's many people who work like that. Cloud use can also, they can also use different cloud services from different public cloud vendors. In other words, a multi-cloud environment because they like different capabilities that are in these clouds. For instance, some may have better rendering solutions, some have better content delivery networks, some have better metadata extraction capabilities using artificial intelligence, for example. And next slide. Cloud rendering is a popular media and entertainment application, particularly for those who don't have the money to buy or support or keep busy their own rendering equipment, or for those who do have their own rendering, but they need more rendering capability than they're currently equipped from. Then they essentially burst out to get more rendering through the cloud. Cloud storage also can use to store disaster recovery copies of content, of course. And there are many organizations that use cloud storage for their active archives. But it's most common for the larger, for smaller. It's more common actually for smaller content, say less than 3 petabytes of storage, because then egress costs and the economies of doing something locally versus doing something remotely start to become less attractive for the cloud storage, at least for some people. Next slide. So let's talk a bit about storage for animation and special effects. So here's a picture of a Pixar render farm. And actually, this is an old one. I actually have a newer one from Pixar, which I would love to put in there. It's got a neon sign next to it. But render farms are used for animation, special effects, and are similar in their use of storage to high-performance computing. These systems are characterized by asynchronous and concurrent write and read operations as new frames are created. High-performance networking and storage access are characteristic of these environments. The large number of files that are created lead to special metadata and asset management situations. And it's an area where remote render services access through the internet have become popular for small and even some large production projects. Now, so oftentimes special processors like GPUs are often used for rendering nowadays. And it's possible with improvements in processing, although you have to weigh this against the size of content, is that we may be approaching a time when actually people, when they're editing, could actually do real-time rendering, at least in some applications, which would really change the whole process and creative process that's done in the rendering, in the editing and production side. So next slide. So a lot of stuff, this work has been done with traditional storage interfaces, or with or a lot of infrastructure in media and entertainment has used special serial interfaces, SDI, which actually is a coaxial cable. But there's changes coming in the use of IP-based networks. There's actually standards with SMPTE, which is one of the organizations I've been active in, that is promoting, it's created standards for video and audio content as well as underlying metadata using Ethernet. And for traditional SDI solutions, for instance, have stood the test of time, but they're harder to advance and move to next generation higher performance. Whereas with these Ethernet-based networks, they can more easily go to higher performance just by changing the networking technology. And IP is also format agnostic, allows mixing multiple television standards on one network as you tunnel through. And if enough capacity is available, bandwidth capacity, then you can do SD, HD, 25 frame per second, 30 frame per second, even higher resolution potentially through the same network, or and the mix, for instance, 4K and 8K technologies into the same network. So it's likely that future HK and higher resolution video workflows will be mostly built with IP connectivity rather than, for instance, the traditional SDI. Next slide. And actually, you'll have to go to the slide after that, because it does one thing on that slide. So this is, again, on the ST2110, which is the SNIA standards for IP-based workflow. Another group out of Europe, the Joint Task Force on Networking Media, JTNM, released this roadmap with dates out to 2020, which shows the progress of standards and specifications, how the underlying technologies for IP-based workflows are expected to evolve, and when it's expected to be widely available to build interoperable multi-vendor systems. Note in particular under item 4 here, dematerialized facilities. This shows the future of IP-based workflows could involve various types of IP-based virtualization in combination of public and private cloud solutions. But I also think this potentially in a data center itself fits into ideas of in media and entertainment applications, moving to disaggregated computing and composable infrastructure. Next slide. We talked, all these things we just talked about relate, have a lot of relationship to this post-production side of things. Before we move on to talking about other parts of the media and entertainment workflow, I just want to show this slide, which again is from the 2020 Digital Storage and Media and Entertainment Report. This shows post-production storage capacity annual demand. It shows cloud capacity, projected demand, local, that is direct, local network capacity demand, and local capacity, i.e. direct attached type storage. You can again see that this was more muted in 2020, although post-production could still go on with remote work. The amount of content that was able to be created for the post-production work was stifled somewhat, and so we didn't see growth in 2020, but we do expect to see continued growth again in 2021 as mitigation measures are taken, and just driven by the general increase in the demand of storage to support these higher resolution, higher frame rates, higher dynamic range, more bits per pixel content. And you can also see the fairly significant growth in cloud storage capacity projections. Next slide. So let's move on to other areas. One of those is archive. And archive may be passive archives, which might use optical disks or or tape, or they may also be more active where they are in a library system or it's an array of hard drives. So one of the terms for this is called these active archives. And an archive can be for preservation, okay, online or offline within frequent access, or an active archive content library for frequent access can be expected. So in addition to archives kept in-house, the use of cloud storage for archiving is also growing in the media and entertainment industry. Again, maybe at that more for lower amounts of content for most people, but there is a trend in that direction. Traditional storage capacity for archiving are removable media such as tape and optical discs that can be put on a shelf or in an automated library system until needed. However, there's a growing trend to use hard drives for long-term storage because access to the content is faster, because those devices are increasing in storage capacity, and also as long as they are competitive versus solid-state storage in actual price per gigabyte or terabyte. Next slide. So here's this is archive storage for media and entertainment. This is some results from the survey, the Coughlin Associates survey in 2020, and it's looking at what's used in archiving here. And on the left-hand side, we can see that external hard disk drives for the people taking a survey, a lot of them were smaller video folks, was the most popular here, followed by local storage networking. A lot of that would be hard drives too, but on storage networking, and then digital tape. Digital tape at 19%. And then if we look, that's the left-hand side. And then there were also people that were using public cloud, private cloud here, or public cloud and optical disks as well. And if you look on the right-hand side, just focus on tape, the highest percentage of tape being used was the LTO format here at 64%. And backup and especially archiving are the dominant applications for magnetic tape in many other places and also in this industry. So the next slide. So this is looking at the growth of archive storage capacity. Again, this is from the 2020 Digital Storage and Media and Entertainment Report, showing that the impact, again, going from 2019 to 2020, because there's less content being created, new digital content, we're seeing a decline there. However, we're still ongoing with conversion and preservation of old analog content, which is still a pretty big reservoir out there. And we can see after 2021 again with the greater resumption of media projects, and again in the future driven by more immersive content, that this demand for archive storage capacity will be growing over time. Next slide. So I want to focus here on remote work and growth of cloud-based workflows in the media and entertainment industry. So that was a change in the slide, and now we're changing to another slide that says media and entertainment uses for cloud storage and services. So there are various approaches that different media and entertainment organizations take with regard to using resources in remote data centers, oftentimes referred to as the cloud. Some organizations are looking to move particular activities to the cloud to reduce their CapEx expenses while increasing the OpEx. Also, as more activity goes on in the cloud, such as rendering and content distribution, it leads to storing more content in the cloud and may pull more use of cloud resources and services for other activities as well. This is often called data gravity. However, cloud-based storage and applications are often considerably more expensive than if the resources were maintained in-house, assuming that the organization has enough experience and expertise to support this kind of IT infrastructure. For this reason, some organizations only use the cloud to avoid over-provisioning with local resources. In this case, they may move some activities to the cloud when local capabilities are maxed out. That's called cloud bursting, and we referred to that earlier, for instance, with rendering. Online cloud capabilities from the media and entertainment industry include multiple tiers of storage, rendering, metadata creation using artificial intelligence and machine learning applications, including voice-to-text and facial and image recognition. Also includes content delivery systems and collaborative work, such as production and post-production. Cloud resources and applications are also a significant part of enabling the remote work, which has become particularly important during the pandemic. So let's go to the next slide. Let's talk in particular about the impact of the COVID on cloud use in the media and entertainment space. With the onset of the pandemic, many media houses had to make a sudden transition from working in a studio to working from home. That trend towards remote work, including remote work with collaborative workflows, which are very common in this industry, had already been underway in the industry. But I'd say it was accelerated by 2 or 3 years by the experience in the pandemic. And although production work during the early months of the pandemic all but ceased, it started to return starting in July 2020, although various shutdowns have impacted it since then. Where it has worked, it's enabled by sanitation, social distancing, and the use of automation to reduce human proximity and new technologies that enable creating realistic environments for shooting scenes that don't require travel. These are things like LED light walls, cameras on robots that can be used to shoot scenes, and things of that sort. Also, special effects using computers became more important in animation, of course, since it didn't require actors, was less impacted than other production work. Next slide. Continuing to talk about the impact of COVID on cloud use. Working at home increased the use of public as well as private cloud resources for production and post-production. People have been uploading and downloading content from cloud storage repositories, enabling them to continue doing their work from home. Several media companies have said that their use of internet cloud resources will not decline going forward in the future, and that working from home will be more common, even when it is safe for people to come on site again. In other words, some of the trends that seem like they've been started in this industry look like they will continue, at least to some extent, that people spend more time working remotely than in the office than they did before the pandemic. And resources used for media and entertainment for work from home have included virtual desktop interfaces to connect to private clouds and applications running on those clouds, as well as various public cloud services, and the use of tools such as Slack, for instance, for work group coordination. Next slide. This is the third slide on the impact of COVID on cloud use in media and entertainment. Overall, the pandemic will have a significant impact on media and entertainment production last year, and likely continuing into 2021, at least until there's a significant number of people who have been vaccinated. During times of social isolation, this technology has been the way that we've been able to continue work. Basically, the things that people like technologists have been involved in doing are the means by which the economy has been continued where it can. Remote interaction using tools such as WebEx, Zoom, BlueJeans, Microsoft Teams, Google Hangouts, Slack, and many others that I can't remember right now are being put to the test for everything from education to conferences and events, and work is being done using these tools. So the capabilities and stability actually of those tools, as well as the networks that support online activities, have been improving as a result of this workout. Next slide. So this is again a slide from the 2020 Tech Retreat, and it's actually the last Hollywood Post Alliance Tech Retreat. They actually did a live cloud-based workflow, and here's a slide from there showing this basically the way that they were moving data around various places in the cloud, various sorts of tools during the event. So it was a very interesting. I mean, it was live. They actually were shooting it on site at the event, and we all who were there were in the scenes to some extent. Next slide is talking about Movie Labs. Movie Labs is a Southern California-based organization that looks at the future of video production, and they've done a lot of work on clouds. And this actually is a presentation. I believe this is also from the 2020 Hollywood Post Alliance, showing the use of cloud and various resources, workflows. That they wrote this book, Securing the 2030 Vision. It's actually, I think, written in 2019, but of course there's a lot of implementation, the accelerated implementation of these things in 2020 and going also into 2021. Next slide. Talking about multi-clouds in media and entertainment. Various public cloud companies offer different data processing options and prices for their services. And for instance, one cloud company may have a better rendering service, metadata extraction, or a lower storage cost, for example. And a multi-cloud strategy, it might also include a private cloud storage, i.e. in your site, but accessible through the internet, is becoming popular in many industries, including media and entertainment. Provides a way to balance data creation, storage, and analysis packages in terms of performance and overall cost for your operations. And a multi-cloud approach requires data management, spans data in the clouds and locally. And there are many companies offering ways to manage multi-cloud cloud storage and other services, and some of them are working, and many of them are also working in the media and entertainment space. Next slide. So this again is a slide from the 2020 Digital Storage and Media Entertainment Report, which is a media and entertainment cloud storage revenue projections that we're seeing growth after 2020. 2020 growth of cloud storage was hit by the reduced from what it might have been because of COVID, the pandemic, but again, projecting that in 2021 and in the future, it's going to grow. It's going to grow because of all these different reasons why cloud storage is useful to people, but it's also going to grow because of the amount of content being created, and it's growing with other types of content as well, and other types of storage as well. And you can see this is again looking at the overall archiving and preservation, video on demand, distribution methods, and also post-production in their growing demand for cloud storage according to the Coughlin Associates 2020 report. Next slide. So finally, we're getting into conclusions and summary. Next slide. This first slide here on market storage revenue share by use, and this is looking at what we think things are like in 2019 and what they will be like in 2025. And in terms of percentage of storage and media entertainment, 2019 content distribution was about 31%, with archiving and preservation at 39%. This is again revenue, not capacity. Post-production at 22% and acquisition to 18%. In 2025, we see growth in the post-production content acquisition and content distribution on the revenue side. And while the amount of archive capacity continues to increase, we actually are looking at the net revenue there decreasing. Part of it is being driven by, to be a good archive, it must be less expensive. But creating this higher resolution, higher frame rate content that we're projecting puts more pressure on more higher performance storage, and therefore more expensive storage on the distribution, post-production, and acquisition side. Next slide. Now let's look at the market share of storage media by storage capacity shipped. In 2019, we projected that about 75% hard drive, tape at about 19%, flash at 3.5%, and optical at 2.7%. In 2025, hard disk drive driven by its higher performance and presumably increasing capacities at about 77%, tape at 13%, down somewhat in this projection, and flash at about 10%, and optical down to about 0.4%. Next slide. Let's look in particular at flash memory revenue by application. In 2019, about 64% of this was used in content acquisition, about 27% in post-production, and then 9% in video on demand. We see that acquisition will, in 2025, post-production requirements for fast flash memory storage will increase to about 33% of the flash, driving down acquisition as a percentage somewhat at 56% in video on demand, also because of the higher performance required for delivering content increase from 9% to 10%. Next slide. So a general summary here is COVID-19 had a big impact on the media and entertainment industry. It shut down and slowed production work and moved most post-production activities to remote work at home. This caused an increased use of cloud resources, including storage, and having been established, that is likely to continue to grow and not decline significantly going forward. High performance, low latency requirements in media and entertainment is driving the use of solid-state storage for many media and entertainment applications. And increasing storage capacity for long-term storage will drive hard disk drive and magnetic tape demand. A continued drive for more immersive content will require ever larger amounts of data for media and entertainment projects, which is good for the digital storage and memory companies. And so these are some of the conclusions here. Here's a reference here. I've got a couple things, actually some high-level results from the 2020 Digital Storage and Media Entertainment Survey are available on the tomcoughlin.com website in the Tech Papers page. Lower down, you can get a copy of that if you wish. And if you're interested in the 2020 Digital Storage and Media Entertainment Report, that again is located on the Tech Papers page on the tomcoughlin.com site. You can find out more about that and even order it if you want to find out more about how these numbers are gotten. It's over 200-page document with lots of figures and tables in it that could be useful to you. And then finally, if you're an IEEE member, I have a petition out now at www.ieee.org/petition that if you sign it would help me to get on the ballot to run as IEEE President-elect in 2021. So with that, Marty, I'll pass it back to you.
Thank you, Tom. So before we move to the Q&A, and I encourage you to ask a question, just wanted to answer one of the questions that we always get at every webcast. We would like to let you know that there is a link to the webcast, and the PDF of the slides are posted on our SNIA Compute Memory and Storage Initiative website. And the link is there. You can also find the webcast. It should be posted by the end of day today as a video, and then many other videos and presentations within the SNIA Educational Library, snia.org/educational-library. And we will be doing a Q&A of this webcast, and we'll be posting it on our Compute Memory and Storage blog. And you can see the link below, sniacmsiblog.org. So as we move to the questions, I encourage you to invite your questions via the online Q&A. So underneath the presentation, there's 3 boxes. The first is ask a question, so type it in. We also would like you to rate the presentation because we always look forward to your feedback so that we can make our webcast even more useful and informative. So please take a moment to do both of those. And Tom, we have 2 questions that came during the webcast. Let me read the first one to you, and you can provide your answer. So the first one was regarding resolution. So the questioner asked when the resolution of the target display device, for example, a mobile phone, a tablet, an older LCD TV, is much lower than the source content, who does the scaling? And the second part of that is data reduced before it is sent to produce bandwidth?
Thank you, Marty. So I think that a lot of times when these mobile devices establish communication, there is information that's transferred that will give information on the display and what it's capable of. I think, it all depends upon the services being used. But again, the second question, which is basically true, if you can reduce it before you send it, reduces bandwidth, and that's very important. So I think there is the greater amount is now being done where you actually make the display data appropriate to the target device. That's perhaps done in the data center, but might even be done at the edge where the actual delivery is done, depending upon the actual network that's being used. But I think that in order to I believe that it is much more often where the delivery vehicle somewhere in the network before it's sent to the user changes the size of the data to match the display device.
Great. So we have 2 more questions. One just came in, but the second question happened during the presentation. The questioner asked, what are the challenges for storage device manufacturers when a device attempts to do typical error recovery, such as bad blocks, garbage collection on flash, etc.?
Sure. So this actually is part of the magic of how companies that sell storage into this industry differentiate themselves, is by how they handle some of these common features. Media and entertainment storage requirements are often for many parts of the workflow are very different, especially the more creative type parts of it than the demands for IT storage. So dealing with bad blocks, garbage collection, you might end up with additional parallelism. You might end up with ways that you deal with it with problems in the data transfer that are going to be a bit different than would be IT. And so that's part of why actually look in this industry or go to any of these trade shows. There's an awful lot of companies that are selling storage, and there's many companies that are selling storage in this industry that have particularly things that they've tuned in their storage to the requirements of people in the media and entertainment industry. And another part of that question was, broadcast companies will often like a drop frame rather than a long delay due to data recovery, and basically that's true. Now it's gotten a lot better with processing capabilities. You can deal with, or the other thing is if I can, this might be another place where if I use computational storage or some other type of accelerator, it can deal more rapidly and locally with an issue versus passing it on to the system. Those are some of the things that may be important in dealing with those. But again, people doing artistic work are expecting very fast response. Anything that creates delays or excessive latency will be a problem to them, and storage systems have to be designed for that part of the workflow to meet the needs of the artists that are using it.
Thanks, Tom. And you did mention computational storage. Just a note that SNIA has a number of resources on computational storage, a lot of presentations, videos, definitions that you can find on SNIA.org. The final question that's come in, Tom, is how do you see on-prem object storage playing a role in the media and entertainment industry?
So I see it already playing a role in archiving in the media and entertainment industry. There's a lot of work that's been going on in our object storage for higher performance applications, and I'm seeing some interest in that, and I think there's possibilities. There's a lot of people with products. One of the things that has been an issue is that a lot of tools used in this industry are file-based, and so the way it deals with metadata and the object storage. To be useful for those tools, you need to have some kind of a translator or gateway or something of that sort. There's getting to be more of those out there. Object storage intrinsically doesn't need to be slow, but a lot of the applications in media and entertainment, others have been on the archiving side, but it's moving. I think there's going to be more and more object storage. Eventually there may be tools that will deal with object storage native. I think there's work going on in tools that will make object storage native in media and entertainment. But I think it's going to be a while before that becomes a widespread standard. So object storage is there. I think archiving is one of those uses on-premise. There's possibilities, I think, with developments that enhance the capabilities of object storage for the media and entertainment uses that could make it more widespread.
Great. Thank you, Tom. Just wanted to mention again that the presentation, the PDF is available on the website, SNIA.org, in the Educational Library, and you'll also can find a copy of the video if you want to rewatch it. Tom covered a lot of topics and very quickly, so if you want to go back and rewatch the video or the webcast, it'll be available later today. So with that, we do have one more. We've got one more snuck in, Tom.
Yeah.
Is the cloud object storage via the S3 protocol a good solution as the archive tier for media and entertainment data?
There's a lot of cloud storage also being used in media and entertainment. A lot of object storage currently being used in media and entertainment, which is on S3 because that is a dominant protocol. Fairly open. People that use it, they're within reason. It's a bit easier to transport from one protocol to another. One of the reasons why people would go to object storage, for example, might be to have a private public cloud or even multi-cloud type environment. So you want to make sure that they're compatible. S3, of course, is one of those important standards, and it's a basis of much of that compatibility.
Great.
And,
all right.
And by the way, if people would like to get a hold of me directly, my email is tom@tomcoughlin.com if you have further questions or interest in some of the stuff I do.
Great. And we'll probably be publishing the Q&A to this on our blog. And if any other questions come up, you can ask them through Bright Talk as well as contacting Tom directly. And I know he writes frequently on this topic on his blog on Forbes.com, so you can actually check him out there. So with that, I want to thank everybody who attended and thank you, Tom, again for presenting on this great topic, and hopefully we'll see you at the upcoming Persistent Memory Summit, which is going to be virtual this year, April 21st and 22nd. So stay tuned at SNIA.org for more details and the agenda, which should be available in February. And we look forward to having you all maybe make plans to stop by virtually at the conference on April 21st and 22nd. So thanks again, and we'll say goodbye and see you for the next webcast. Take care.
Thank you, Marty.